Well, thank you everybody for taking the time out of the day to attend this presentation. Um, Thank you for the organizers for putting this together. This is really awesome that you guys are taking the time out of your day to organize this event. I absolutely love all of these kinds of events. This is where a lot of my learning comes out of, so very excited to be part of it. Um, so I am Brijeet Akula. I am a consultant working for a company called Nordic Global Health. We're a healthcare IT consulting firm, primarily working with in the Epic space, and get into things like data analytics, cloud platform development, interoperability development for hospital systems, um, essentially all kinds of things in the custom development space with data and software development. Um, a little about me. So I have about 15 years of experience primarily in the Microsoft data stack. I come from the um, from the SSIS, SSRS world that you guys are all familiar with. SSIS especially, I was a very heavy user of that in my past life, doing all kinds of ETL stuff. And then over the course of the last several years have been shifting more into I've been shifting more into the cloud space. So that's how ADF gets into the mix. I also organize, similar to this, events in the Madison, Wisconsin area. I've actually been lucky enough to be able to do some in-person events for the last few months, which is great to see. So hopefully we can keep that up. All right. So this was a little bit more about the company I work for, but we already kind of talked about it. So we'll skip this. And we'll get started. So I'll start with just what the traditional world used to look like with SSIS. Traditionally speaking, you have this one massive server that is hosting all of your SSIS packages. Just like any other ETL tool, it's supported for you to be able to bring in data set from any kind of a on-prem system, whether it's databases, flat files, even some web services and things like that, and then output to whatever you wanted to do. It was great, worked pretty good, but just with traditional on-prem things, you're limited to the box that it was running on. Most people usually went out and got a fairly beefy box to support these ETL activities because you may have to handle some really large ones, and other times you may have to handle fairly lightweight things that's only dealing with like a million records or something like that. But this is what the typical setup kind of looked like. The main thing here is scalability. Obviously, was very limited. If you needed more resources, you would have to work on either getting a new VM, upgrading the box itself and stuff like that. Now in our exciting new world of the cloud, this is what the picture kind of looks like. It's still supporting your ETL design pattern, but one of the advantages that comes with this is we have virtually limitless options for source and destinations. With all things in clouds, they are constantly adding more and more stuff to this product offering. So there's constantly new connectors being added into Azure Data Factory, allowing you to connect to a huge variety of sources. Your traditional databases like SQL Server, obviously the Microsoft product, obviously, but online services like Workday, ServiceNow, SharePoint, things like that. Other data sources like flat files and things like that coming out of blob storages, coming out of data lakes, and also other cloud places like AWS or even Google Cloud. And you're still able to connect to on-prem stuff with some additional configuration stuff. So we'll be looking at that. The other piece, like everything else with the cloud, it's highly scalable. So the big benefit here is not all of your jobs might be massive, so you don't always have to have this massive beefy server that's going to host your ETL process. You may have like a dozen or so jobs that really only take like 30 seconds, a couple minutes or so to run, maybe just as a simple extract to send out to an external vendor, or you're receiving, fairly lightweight files on a regular basis that it doesn't really need all that extra muscle. So this way, because it's highly scalable, you're only going to end up paying for the few minutes that the processes are running, instead of having to have this big machine just sitting in your data center at all times, paying for the SQL core licensings and things like that. One concept that takes a little while to get used to, and we'll be talking about that a little bit, is your compute and storage are separated. In the cloud, all of the compute and storage being separated is a very common concept that comes up all the time. So the raw files might be sitting in a blob storage area somewhere, but the ETL, the actual processing piece, is then being done in a separate process. So the big difference that happens here is you always have to think about your process being able to read the data set that you're working with. So there is a little bit of extra data movement that happens. Whereas in the traditional SSIS world, for example, there's a lot of times where you're just reading a file and doing all the transformations right then and there, because everything's happening locally on just that same box. So there's some extra things that comes with this, and dig into that a little bit. One big development from the traditional world is modern development practices. So things like source control comes in. It's natively built into this tool, which in our SSIS world, that didn't really exist. It's always a good practice to put things in source control, but it was always an afterthought. You had to actually configure it. You had to get some kind of plugins to work with SSIS and SSDT to actually make this happen. But as we go into the interface, you'll see it's actually part of the provisioning process. It'll ask you where your GitHub repo is, whether it's a GitHub repo or a Azure DevOps Git repo. So it's really good to see that. I think I saw an alert for some question. Was there a question that popped up, or is that just in the chat?
There's multiple questions. Let's see. First one. I think truly we're going to go through most of the stuff as we go through the presentation. Okay. So if you just want to continue, and we'll go. If there aren't any, if you don't answer it, I'll ask at the very end.
Sure. Yeah. Feel free to interrupt me at any time, though. So I want to start with what the user interface looks like in Azure Data Factory, and start getting used to some of the new terminology that comes with this interface. So this thing here is just showing, so the thing on the left-hand side, this is obviously your Azure Data Factory, and then the thing on the right-hand side, this is a little snippet of what your traditional SSDT looks like. So in the SSIS world, you are typically creating a Visual Studio solution, and typically the solution contained a bunch of packages that pertain to a specific solution, or maybe you create a one Visual Studio solution for just like one data warehouse, and it might have like a dozen or so packages, or keeping the solution to one integration thing. So integrating your system to some HR vendor or something. So it has everything revolving around that. So that is what a data factory is in the cloud. So every time you would think about creating a new Visual Studio solution, you would be creating a new Azure Data Factory resource in Azure itself. And then all the stuff would live inside that. So all the packages and things like that. Then talking about packages, so your SSIS packages here on the right-hand side, your DTSX files. The comparable item to that in the data factory is called pipelines. Pretty simple. Connection managers is a little different in the data factory world. So traditionally you had like global connection managers, or you would have like those package level connection managers, but essentially you just have these connection managers, right? It was just basically just a connection string to whatever. So for example, it would have your connection string to your on-prem SQL Server or Oracle or something like that, and details about authentication and things like that, what database it's connecting to. That's handled a little differently in the data factory world. It's broken up into two pieces. So there is a thing called linked service, and that kind of relates more directly to what your traditional just quote unquote connection string would be. So the linked service just is setting up the driver. So for example, if it's if it's trying to do like an ODBC connector, if it's connecting to Oracle or SQL Server or something like that, the target itself, and then the connection details of the IP address, the host name, what the credentials need to be, things like that. Then there's a new concept that gets introduced called data sets, which didn't really exist in SSIS. I would kind of compare it to what data sets looked like in the SSRS world. So these are just like representation of the query of either your source or destination. So if you were pulling in, let's say, a department table from database X on this one particular SQL server, so you would have one data set that's essentially pointing to that, and then you work with that data set through your ETL pipeline. And we'll take a little bit more to that. Okay. So another thing that takes a little while to wrap your head around, it certainly did for me, is your IDE, your integrated development environment. You don't have a software package that's on your computer anymore. So you're not opening up Visual Studio, or you would even think, well, this is cloud. If you use something like VS Code, maybe I would use that to do my development. That's just not the case. All of the development, your integrated development environment, so that the Visual Studio thing, equivalent of it, would be the data factory itself. So you're going to go to, for example, adf.azure.com and load up the specific data factory that you want to work in, and then do all of your development there. And any of the changes, you're hitting save, and it's being saved out there on the into the cloud directly. So there's no files, there's no DTSX files, there's nothing that would actually be sitting on your computer at all. So it's a little interesting, but it's definitely the direction, right? All of these cloud things are heading towards. One big thing, not that anybody is still using classic Internet Explorer anymore, but I wanted to call that out. Yeah, it's not going to work. You have to use a modern browser, so something like Chrome is needed. I'll get into a little bit of Azure Basics just in case you guys if there are folks on this call that haven't delved into the Azure world that much. There are two concepts to kind of keep in mind. The first thing is going to be resource groups. This is just a logical container where you would put all of your resources inside. So especially for these kinds of presentations, typically what we would do is we would just create a resource group called like Cloud Data Driven Presentation or something, and then I would create everything inside that. And then once I'm done with it, I can just delete the resource group, and that cleans up my Azure environment, and stop getting billed for services and whatnot. It has no impact into anything you're developing at all. It's just there for organizing your stuff that you have out there in Azure. You can use it to then set permissions. So like in an actual production environment, maybe you would create a resource group just for a specific solution, or maybe for a specific team. And then you set up permissions at that resource group level. So everything inside that, the people have permissions to. So that's really all it is. I'm bringing it up because it will be something that comes up when we create our first data factory. The other thing to keep in mind is regions. So Azure, right, it's in the cloud, but basically it's a bunch of data centers spread out all over the world. And so whenever creating any resources, it's always going to ask you which region do you want to be in. And this goes back to the concept of compute and storage being separated. So you always want to make sure that you're picking a region where everything else is. So if your data, for example, is sitting in the North Central region, which is Chicago, and you decide to create a Azure Data Factory resource in the East region, which is out in Virginia. So the ETL part, so all the processing, right, the transformation. So your file is essentially going to go from Chicago to Virginia to do whatever. And then if you're outputting it back into a folder that also happens to be North Central, it has to go back to Chicago again. So as you can imagine, especially for really large files, stuff like that can cause issues. All right, so I will send these slide decks out also, so you'll have this for reference. But this just shows like what the stuff looks like when you want to create your first data factory. But we'll just create one here. So I've got my Azure portal. And I'll just use the same resource group that I've been using, that I used for the presentation back at Past Summit a few months ago. I'm going to, there's many ways to do it. So here, once I get into my resource group, I can come here, hit create, search for data factory from here, and then hit create. My easiest way is usually I just go from this global search area, type in data factory, which just shows all the data factories that I have, and I can just hit create. So then this is the set of windows to go through to create your first data factory. So the very first thing it's going to always ask you when you're creating any resource in Azure is what resource group to put in. Again, remember, this is just the logical container where all of this stuff will live. If I wanted, I could create a new one, and this would create this new one on the fly and then go from there. I'm just going to use one that I already have. And then region, it's going to ask you what region to go with. I'm just going to go with North Central. So cloud data driven demo. Hit next. Okay, I must have just had a space or something. So hit next, and here you'll see right away the before you can even proceed, it's asking you details for source control. So this is really great. It's like I said, it's baked into it. It also kind of forces you really good practices by having you put in your GitHub or Azure DevOps information. I'm going to ignore all that and choose to just skip it. But yeah, you can also configure it later. And then it's got some other advanced settings we're not going to go into. And that's it. So that creates your first Azure Data Factory. And then now you can see it. This is in your portal. Accessing your data factory itself. Again, remember that all of the development, right, is done through this web interface. So you have to get into it to start authoring your work. So you can do that also multiple ways. You can find the resource here in Azure Portal and then click this link, which will launch it, which will take you to the studio like so. Or you can just go to thing directly, adf.azure.com, and it'll have you log in. And then you're given with this one, which is basically it logs you in to Azure AD and then gives you a selection of which data factory do you want to actually edit. And it'll show the ones that you have access to. So. And yeah, this is our first ADF. I'm going to flip back to the slide to talk about the interface because we've got all these red circles and things like that. It'll make it easier to talk with. And so this is what your user interface looks like. So there are a few different areas to be aware of. Starting with number one, your pane selector out here. So this is going to select the different panes in this environment. So you've got a pencil icon, that is the author pane. So as the name suggests, author, so that's where you're going to be developing most of your work. So you'll be creating those pipelines and the data sets and actually then developing the transformation and whatnot. So that's all in this section. This icon here, that looks like a dial, so that is the monitor section. And as the name suggests, that's where you would go once everything has been created and you actually have stuff running. This is where you can go to then get information on that. Even things that you run in quote unquote debug mode, you would have to go into this monitor section to then see the logs, the results, error messages, things like that. This briefcase looking icon, that is the management area. This is where you'll have some other higher level configuration stuff like linked services. So the connection strings to those things like the SQL servers and whatnot. Integration runtime, which we'll talk about in a minute, and some other management stuff's going to be in there. Then this box number 2, this thing here, this is the open tabs. So as you're clicking around and you click on different items, it's going to show up in here in a tabbed-like environment. So think about like Google Chrome and whatnot, right? You'll have multiple tabs in here, and you can flip through that and actually do the work inside there. All of them are going to have a very similar look and feel to it. So there'll always be this bottom area here, the properties area of the object that you're selected on. And so this is very similar to the interface in the SSIS world. If you remember, wherever you clicked on, then wherever you had that advanced properties pane, it would show you the different things that you can change. Same concept here. So for example, if I'm clicked into just the empty canvas area, it'll give you different sets of options versus clicked onto one of these objects. It will give you properties specifically to those objects. And then here on the number 4 area, so we are right now in the author section. So it's got the contents of that. So there's pipelines, data sets, data flows, and so on. Before we go back into the user interface, I just wanted to show this slide. This is to just give you an idea on what kind of connectors are out there. And this was done back in October when I presented this for past summit. So chances are there's probably at least half a dozen new icons that aren't on the slide. I have a link in here for the official Microsoft documentation so you can look at the list, but kind of gives you an idea of what is out there. And it's essentially anything anybody would normally be working with, you'll be able to connect with. Including non-Microsoft stuff, non-Azure stuff. So for example, Amazon Redshift, that's AWS's data warehouse product. There is a Google BigQuery in here somewhere. Google Cloud Storage, the Amazon S3 buckets, Oracle stuff, Salesforce stuff, Snowflake stuff. So it natively supports the hybrid cloud environment. All right, so going back to this. Okay, so we'll just quickly walk through this stuff again. So here on the homepage, again, it'll give you a warning message that, hey, you don't have this hooked up to any kind of search control. So I really like that. It really promotes good development behavior. So this is that author section. It's pretty empty. There's nothing in here right now. The monitor section, this is where you will see the executions. So pipeline runs, for example, remember pipeline is essentially your DTSX file. So here you can see things that were executed. Debug mode is what you would typically be in when you're still developing. So you'll see the runs in here. And then going to the management area. Here's your linked services. So this is where I would set up a connection to something. So let's just say like SQL Server and enter the details. Integration runtimes. So this is the concept of your compute and storage being separated. So integration runtime is the actual piece of compute power that your execution gets essentially attached to when it's going to do the work. So this one, this is the brand new one that we just created. So this is something that comes with every single data factory, the auto resolve integration runtime. So this is just baked into it. You don't even get to select which region this process is going to be in because it's just handled automatically by ADF. So whenever you do create any of these pipelines and then you hit execute, behind the scenes, it basically finds a compute resource somewhere, attaches it to that, and then does the work. And then you're billed down to the second for that execution time. So if it takes, 50 seconds, then you're billed for just that piece of it. So this is really where the flexibility comes in. We're also then able to create new integration runtimes. This is where we would, for example, create an integration runtime that helps connect to on-prem places and other dedicated integration runtimes. We'll come back to this in a moment. All right. Okay. I think what I'll do now is just we'll take a look at a few stuff that I have already opened up. So this Azure Data Factory demo number 5, this one is just a very, very basic ETL thing. It's going to read in 3 different files, invoice lines, and customers, and import them into a database. So here, if we do all right, so we've emptied this out. This one we'll walk through it. So this pipeline, right? Again, remember this is like your DTSX file. So I have 3 copy activities happening. Similar to SSIS, you can do the dependencies and stuff. So if by doing this would mean that this has to run first and then this will run. If I don't have that at all, then basically all 3 of them will just run at the same time.
We'll go very shortly now.
Okay. Okay. So
come down for lunch.
Okay. So copy data. If you see here, as soon as I click on this, the bottom area is going to change with the settings pertaining to that. So the copy data activity, this is one of the most common things that you guys are going to use. As the name suggests, this is performing a fairly simple copy activity. It can be used for essentially copying a file from A to B and deleting it at source. So if you're just moving files, but also it can be used for the E and the L part of the ETL. So simple extract from wherever or read in data from wherever and load it into your destination. All through ADF, the terminology that they use all over the place is source and sink. So instead of using destination, they use sink all over the place. So for this copy data activity, my source, I've got it set up pointing to a text file. And if I hit open, it'll show you the connection details. So this one is using a blob service thing that's called demo blob. It shows you the path to it. So it's in this container inside this folder, and it's the invoices.txt file. So if I go back here. So here is my storage account. This is your blob storage in Azure. So basically just a big network drive, simplicity purposes. So here's demo data in, and then here are the files that we are working with that we're going to be reading in. So that's what that is. Where's my import basic? Okay. And then sync, the sync is set up to this data set. So I just gave it a name. So this one is called invoice table, for example. If I hit open, it will show you the details. It's connecting to Azure SQL database. If I hit edit, that will take me to my linked service. So here it shows the actual item. So it's connected to an Azure SQL database, the name of it, authentication, stuff like that. So once I set up my source and sync, so basically take this text file and put it into this table that is set up here. I selected my invoices table. Oh, sorry, I'm bouncing around a bit. One of the things, especially for when your destination is a database type destination, one of the options that it gives you is this thing, the pre-copy script. So in typical ETL patterns, you're, especially in staging tables, you're typically doing a truncate, load this new data set, and then do something with it, right? So typically in SSIS, you would have that as a execute SQL task or a store procedure, and then you would do a data flow task. In here, it's kind of convenient. It's built into the one process. So in this case, it's going to truncate my dbo.invoices table and then do a bulk insert. Mapping would be similar to what you're familiar with inside the data flow thing. Because I'm not doing anything fancy, I haven't defined it in here. It's essentially just going to take the file. In this case, for simplicity purposes, all the column names and all that kind of stuff matches. So it's just going to do a simple import. So let me just hit debug. And here at the bottom part, it'll show me stats that we can take a look at. One thing, it is a little slower getting started. And you'll notice this when working with this. So typically in the SSIS world, this would have already been finished. As you saw, those text files were really tiny. 300 kilobytes, this is 55 megs, 60 megs, but still, even that for SSIS, that's nothing. So it would have been finished by now. And this is, one of the things that just comes with it, because compute and storage is separate, so your compute power is somewhere out there in the farm. So when you're hitting execute, or in this case, when you're hitting debug, behind the scenes, Azure is essentially taking this process, putting it into queue somewhere, finding the next available computer to use to execute this work, and then finally doing that work. So it may seem like slower, but obviously for really large files, this is going to outperform SSIS any day of the week. But right now, for these tiny little things, it seems a little slow. So the customer one is done, and just to prove that the data made it, we had deleted everything. And there is our data. Now we can take a look at, okay, so then the second one's done too. Now here in the output area, this is another important area to get familiar with. As you can kind of see, as I'm hovering over it, there are some icons that show up. And these icons are going to be used over and over again throughout this ADF interface. you're going to typically see these two, input and output. So the input is all of the arguments that went into this process. Everything is in JSON. So in here, it's all of the settings that was in that copy data activity. So especially when you're coming back and doing debugging, you can see exactly what those arguments were. So for example, the pre-copy script, we can see exactly, the fact that there was a pre-copy script, and this is the command that we had sent, and other settings related to that process. Then the output would be more just metadata statistics about the thing that happened. So for example, in the file, it read 663 rows, copied 663 rows, duration. This thing here, this is what you get billed for. How many, in Azure, they make up these fake units for everything. So for ADF stuff, it's DIU, data integration units. So your DIU hours was this value here. So you'll get billed for the 0.06 hours at whatever rate this is. And then all sorts of other stats about it. One of the good things about this, though, is being that it's in JSON, it's easy to work with. All of this metadata is accessible by any other downstream processes. And we'll see that in one of the other more complex pipelines I have here. So you could essentially, like, instead of getting row counts, that was a fairly common pattern in SSIS world. We used to throw the row count component inside our data flows and capture it that way, right? So in here, we can just read this directly from our metadata. So we can get output dot rows read and get that value and store it into a variable and then do stuff with it. Now, especially some of these items will have more metadata that you can actually look at. So this sunglasses thing, we can click on that and it'll show you some more stats. Which is it's just a nicer summary. But this thing I want to call out, this piece here, because it shows you all of the different things that were happening in the amount of time it took. You'll see this in all of your processes. As I mentioned, it takes some time to get attached to some compute resources. So in this case, we were waiting for up to 4 seconds before it could find a compute resource to execute this on. All right. Any questions about this so far, this interface, before I move on to some of the more complex ones?
No, I think this is rather self-explanatory. So it's all good.
Cool. Okay, so far we haven't done anything that you can't do in SSIS, and what I really want to get to is one of the benefits that that ADF provides straight out of the box, which is just fantastic. So this one here, this is the metadata-driven demo. We're going to do exactly the same thing. We're going to take 3 text files and insert them into 3 tables on the destination side. But here, this was the most basic, but also very manual way of doing it. Let's just take a look at all of the stuff we had to create to make this happen. I had to pull down an activity for each of them. So I had to pull down like this, copy activity and configure it. Then I had to configure my source and sink for each of them. And also the data sets involved with it. I had to create one for each of them. So there is a source, what am I looking at? Invoice. So I created a data set called source invoice text. And this is, all the details about that CSV file. So what is the delimiter, the row delimiter, all that kind of stuff. Where is it located? And then the corresponding destination. So I called it DST invoice table. This is just my naming convention that I use and stuff. So TBL, right, makes it very clear that this is a table versus this is a text file, and DST and SRC, that kind of stuff. So we have a lot of stuff. We have a lot of stuff that we created for a fairly simple pipeline, right? It's just doing 3 things. And this is not scalable. So especially if you're doing the large data warehouse load with 200, 300 tables, this would just be insane. And this used to be, this is still a problem in SSIS, unless you're using some other things like BIML or other third-party plugins from something like Cozy Rock. You're forced to pretty much doing it in this fashion. So ADF, ADF makes it a whole lot better. So this pipeline here, and I wanted to do it in the presentation itself, and I realized that the presentation I did at Summit, it ended up being like 90 minutes long. So I'm just going to demo or show bits and pieces of already finished products, just to interest of time. So we're using a new activity in here called get metadata. And as the name suggests, it is a metadata thing. So this typically is used to get things like file listings from a folder. And that's exactly what we're going to be doing here, is we're going to tell it to scan this directory and get the file listings out of there. Let me just get this. Okay, cool. So this thing here, again, it needs a data set. All of these resources are going to need a data set that it's going to work off of. So here I've given it details. You'll notice that this doesn't say a CSV, and this is done intentionally. I don't really want it to bother reading the contents of the file, try to parse it, any of that stuff. I just want a simple listing of what is there. Whether they happen to be files or folders, that's about it. So that's what this is. So you're giving it a path, demo data in folder, and then this is just empty because I'm having it scan the folder. So this is the data set that it's going to iterate over. And then this activity here, you can have it choose what is it that you wanted to return. So in this case, I want a return of all of the child items, which is my listing. I'm then able to pass that into a for each loop, which is also something that existed in SSIS, but the ADF's for each loop works much better. The first item that I want to point out is natively it runs in parallel, which is just amazing. So especially again in the pattern that I have, like 200, 300 tables, it's going to execute whatever's inside this in parallel or up to whatever limit I set it to, which is controlled with this parameter here, batch count. And if you click on this, maximum number of parallel runs. So I could put a upper limit of like 2, because we only have 3 files. And what this would then do is up to 2 executions or up to 2 parallel runs inside, and then it would do the third one after. Or if I wanted it to be run sequentially, then I can check this box and just do it more traditionally. So this is fantastic because it'll scale up. I believe like the integration runtime, the default setting is something around like 50 executions that it can do straight out of the box. This setting is obviously here to help you as a developer can control this, right? So if you're hitting a fairly busy server on the destination side, maybe 50 large table loads simultaneously might be too much. So you can control that here. The for each loop. Now the items here, this is the list that it needs to iterate over. And if I click on it, it brings up this nice little expression builder. And this is where a lot of the dynamic stuff is coming in. So here I've given it a specific expression saying, take I'm referring to this activity thing here. So get file listing dot output dot child items. And let me just execute this while we wait for that. We can continue looking at stuff. And then inside the for each loop, I have a copy data activity. So this is, instead of having to build these three things, I just have the one copy data activity because it's just the one pattern, which is truncate, read, and load. And so this one thing is going to take care of all of that. The big difference is everything would just be parameterized. So my source, it has a generic data set, source text file. I've got the name of the text file is parameterized. So it's, in this case, it would be item.name. The destination also has been parameterized because I want, obviously I want the invoice text file to go to the invoice table, customer text file to go to customer table. So in this case, everything's going into DBO, but we could also parameterize that, the table name, and then even this pre-copy script here, as you can kind of see through this formula here, I'm preparing my SQL statement that's going to be executed. So in this case, truncate table, DBO dot, and then I'm just getting the name of the table from my actual file name. This one's obviously doable because I've kept things pretty consistent. So invoices.txt would map to the invoices table. So keeping that stuff pretty easy. Mapping, this is a huge change from the SSIS world. As you can imagine, SSIS was also, it uses its metadata very heavily. So those data flow tasks, it had to first read all of the columns that are in your source and all of the columns in your destination, and it needs to match up in order for it to run. If you had any of the metadata change that happened, your SSIS stuff would fail. In this case, this mapping can be done on the fly. And that's what gives you the ability to do this kind of dynamic load, where you don't have to predefine those things ahead of time. So if I go back here, this thing ran. So I wanted to wait for an execution to come through so we can see what this output looks like. So this get metadata, which I called get file listing. So I can hover over this, and then if we look at the output, because you may be wondering, like, how did I make that formula? And this is this is my process for it. You could certainly go to the Microsoft Docs to get like what the JSON looks like. But usually the way I pretty much do it is I would start with this get metadata, configure it, hit execute, and then take a look at what the output looks like. And so this is the JSON object. And this object is then available for you to use for downstream stuff. So we wanted these things from there, the file names. So that's going to be the output JSON object dot child items dot name will get me this thing. And so typically what I do is I copy this JSON, put it in Notepad while I work on the other one, so I can copy and paste, exactly what those element names are, to avoid any typos or anything like that. So now if we this. And we come here and look at settings. Now this will make a lot more sense. So if I bring this up, here is that formula. So this is where that came from. This is the name of the previous brick, right? The activity. So it's called get file listing. The bigger JSON object was called output. So that would be this output dot child items. And so now in the for each loop, this array is being sent into the for each loop. And so inside that, I'm going to want the name attribute, and that's what's happening in here. So now I'm inside the for each loop, and so here I'm doing item.name, because then like these are the items that got passed into it. If I wanted to do something with the type, right, I could also get at this attribute. So this allows you to, very, very dynamically create a pretty efficient pipeline. And if we take a look at the data sets, this is much cleaner than what we were seeing before, right? I had all of these different things that was hard coded to the individual files, to the individual paths. Instead, it's just a few items. So let's take a look at one of these data sources. So creating this parameterizable stuff, it takes a few extra steps of creating parameters all the way through. So first I'll start with the data set. I've got the data set here. Come in here and create a parameter. So this is your placeholder. Let's say something like demo param, it's string. And then going back into the settings, any of this, well, we'll do this actually. Text limiter. And I could give it a default value if I wanted. So go to connection, and any of these items I can change it into a parameter. It gives you the default options to select from, but I could go hit edit and then erase that out. And now you'll notice like this thing is popping up. And so if I click on this, it'll give me my expression builder. And now there's a parameter called text delimiter, which I just created. I can click on that. That's it. So that creates my text delimiter parameter. Now this parameter has been defined at the data set level. So if I go back to the pipeline, and go into the copy activity that's using that data set. Now this parameter shows up here. And so I have to do the same process here. Now where I'm using it, I have to map something to it. So I could, in the pipeline, in the pipeline itself, create a variable for delimiter, and it can be a setting I can change at any time, or set it up as a parameter, which means that that gets bubbled up at execution time. So the person is presented with, give me my network path, give me the delimiter, give me whatever, those kind of things. But just for simplicity purposes, we'll do. And so now this pipe gets sent into my process. Let me actually put in some gibberish to force a failure to happen. And we can see what that can look like. Okay, well, okay, good. I thought it was going to take a little longer. So it's good. Now we've got some error messages to look at. You'll notice as I'm hovering over it, there's a different icon that showed up. And this is how you can get at those messages. And yeah, so in this case, I told it the delimiter was semicolon. Therefore, when it read the flat file, it didn't see a semicolon, right? So it's going to just assume it's nothing but one big fat wide column. And so when it takes that and tries to put it into the destination side, there isn't a column called all of this, right? And so obviously it failed. All right. We have about 5 minutes. I want to quickly go over. One thing we didn't go over is the difference between copy activity and mapping data flow. So far we've just been working with copy activity. It's a very, as you saw, it's a very simple extract and load kind of work is what you do with the copy activity. There is no transform going on in there at all. So for the simple extract and loads, this is great. It's very scalable. It's also very cheap from a resourcing perspective. So especially if in your ETL pipeline, you're definitely going to have some areas where, right, you're just staging the data, right? Picking up text files from your pickup folder and importing into a staging folder, a staging table or something, and then you'll do something. So that's where copy activity really comes in. Then something that's more similar to what used to be the data flow in SSIS, in the ADF world, it's called mapping data flows. And let me show that. Yeah, it is in this one. So in this pipeline, it has one data flow task, which is defined here. And this is what the mapping data flow looks like. This looks fairly similar to what was inside data flow tasks in SSIS. The big difference here is this data flow task that I have created here. It's reading two different flat files, doing some joins, and it's going to split on a specific column to output two different flat files for, I guess it's splitting on customer name. This key part of the ETL behind the scenes is being executed on a cluster of Databricks. And so this is where it is able to give you massive amounts of compute power that you typically wouldn't have in your SSIS world, right? Without having to, again, plan ahead of time of having this, having a big beefy computer to run on. With Databricks, it also brings in all the extra fun that Databricks brings in, which is the PySpark engine beneath it all. And the benefit here is you don't have to learn Python. You don't have to learn PySpark. It's got a simple low-code, no-code design where you can configure this stuff, but it is behind the scenes generating the PySpark code for you. And also taking care of the Databrick stuff behind the scene for you. So you don't have to, ahead of time, create the Databrick clusters, any of that management stuff. Similar to the rest of the process, it'll sit there and find a cluster to execute your process on, do the execution, and then you're billed for, the few minutes that this runs. So I wanted to touch base on that. So there is that big difference between the copy activity and mapping data flow, and there is also a cost difference. So the mapping data flow, as you can imagine, I'm using terminologies of cluster. This is lots of compute power you have access to. It is obviously going to be a little bit more expensive. So when doing ETL development, if you're not doing any real transformation stuff, then I would just stick to the copy activity. It's just cheaper to do exactly what you're looking to do, and only pull in the heavy item for that kind of work. Lastly, I want to talk about on-prem connectivity. There is a process that allows you to connect to on-prem stuff. I talked about integration runtimes. So this is the compute piece of, this is where the compute is happening. Everything comes built in with this. This one has a integration runtime set up. So in this one, I have it already hooked up to a virtual machine that has the integration runtime installed on it. And it's a very, very easy process. You download this executable. It's about like 700 megabytes or so. This is what that screen looks like. And then from your Azure Data Factory, you essentially connect your Azure Data Factory to this executable that's going to be living on an on-prem computer. And that's what provides it connectivity from the cloud to your on-prem network. So then I can start connecting to, your on-prem SQL servers with your internal IP address, like a 10.IP address or something. And this thing essentially just acts like a gateway. So it, opens up limitless possibilities for bringing data in from your on-prem stuff. And so that's what this thing is once it's set up. You can have multiple nodes, or you can have it distributed. If you're doing lots of ETL work in parallel, you may want to expand that a little bit more. And for here is that. Sorry, I keep moving my window because this thing is blocking some of the stuff. But here on this virtual machine, this is that integration runtime. So this is the little executable. It just acts like a daemon that's running on this VM, and it's providing connectivity to my on-prem SQL Server. So I have a SQL Server in here, and just a demonstration. 1020.038. So here, I'll just create a quick connection so you guys can see what that's like. Hit new, connecting to a SQL server, continue, call it on-prem. The important thing is any of these things is going to ask which integration runtime to go with. So all Azure stuff, you would leave it in the auto resolver. But for this particular case, I need to use my self-hosted integration runtime. So it's this one here, and then 1020.038. And yep, I'm just going to use the SA password because all right, so I'm going to hit test connection and it should succeed. Maybe not. All right, there you go. So we were able to connect from the cloud to this on-prem computer using the self-hosted integration runtime. Now, if I tell it to use this Azure one, it will fail. It's going to time out, but yeah, it's going to fail. So,
Awesome.
all right.
Good.
Yep, that was pretty much it. All right, I think I ran out of time, but are there any questions?
There is. Could you theoretically replace SSIS with Azure Data Factory using all on-prem data?
Yes, so using this integration runtime, the self-hosted integration runtime, you could certainly connect to on-prem systems. But if your source and also destination is on-prem, it probably wouldn't make the most sense because your data is going to go from on-prem into the cloud for transformation and then come back to on-prem. But you could certainly do it. And it does, there is also ways for you to just migrate SSIS straight into ADF. So because Microsoft obviously wants you to go to the cloud. So you could do a lift and shift strategy. So instead of using your SSIS box on-prem, just use the ADF. But again, if everything's on-prem, there's a lot of data going in and out of your data center into the cloud and back.
Right. And it looks like a lot of questions are centered around that, but I think you answered that very well throughout the presentation. The last one I have is about, and I can't seem to find it. Oh, here it is. Can ADF accept mainframe data straight from the box, or do you know?
Oh, I'm not sure. Mainframe data. I did see DB2 as one of the. Is DB2 considered a mainframe? I don't think so. I would imagine if you can do kind of an ODBC connector, maybe you could get away with it. Not sure.
And like you said, though, for the most part, you wait another week and Microsoft will add more connectors. So, yep.
Yeah. I do believe there is I know there is some IBM connectors in there. Let's just quickly. Yeah, there's info. Is DB2 is not considered a mainframe, right? DB2 is like a.
I have
Yeah, I'm not
seen
sure.
people refer to it as a mainframe. So,
Well, so there is a DB2 connector and an Informix connector. Yeah, we'll have to. I would be very curious what the use case there is.